channel. So today we will discuss about Biot-Savart's law and its applications. A current carrying element always produces a magnetic field around it. It is convenient to assume that this magnetic field is due to the contribution from different segment of this conductor, and this small segment is known as current element. The current element is usually denoted as dl, which has the same direction of current. From the series of experiments conducted on current carrying conductors of simple shapes, two French physicists, Jean-Baptiste Biot and Félix Savart in 1820 deduced an expression for magnetic field due to the current carrying conductor, and that law is known as Biot-Savart law. How to state Biot-Savart's law? So here we consider a current carrying conductor. XY is the current carrying conductor, where I is the current carried by XY. The direction of I is given. It is from X to Y. In order to find the magnetic field at the point P, we are assuming a current element dl on XY. So we wish to calculate the magnetic field dB at the point P. Let R be the position vector of point P with respect to the current element dl, and theta is the angle between this position vector and dl. According to Biot-Savart's law, the magnetic field dB at the point P will be directly proportional to the current carried by this conductor. So this is the first equation. The magnetic field is also proportional to the current element. So I can write dB is proportional to dl. Second equation. It is also proportional to the sign of angle between dl and r. So I can write this as dB is directly proportional to sine theta. Let it be the third equation. And Biot-Savart's law, just like the Coulomb's law, it is also an inverse square law. So we can say that the magnetic field is inversely proportional to the square of the distance between them. So dB is inversely proportional to r square, or directly proportional to 1 by r square. Let this equation be number 4. Comparing the equation 1, 2, 3 and 4, we can write dB is directly proportional to I dl sine theta divided by r square. dB is directly proportional to I dl sine theta divided by r square. Or I can write this as dB is equal to Ki dl sine theta divided by r square, where K is the proportionality constant. Here, the proportionality constant depends upon the medium in between the point P and the current element dl. So we have to choose a proportionality constant which makes the dimension of left side and right sides equal. So it depends upon the unit as well as the medium in between the point P and the current element dl. So here proportionality constant is equal to mu 0 by 4 pi, where mu 0 is known as the permeability, where the value of mu 0 by 4 pi is equal to 10 raised to minus 7 Tesla meter ampere raised to minus 1. Now, instead of K, we can write mu 0 by 4 pi in this equation. That is, dB is equal to mu 0 by 4 pi I dl sine theta divided by r square. This is Biot-Savart's law. Now, we can write this equation as multiplying r in both numerator and denominator. I can write this equation as mu 0 by 4 pi I dl r sine theta divided by r cube. Just multiply r in denominator as well as in numerator. Now, this dB, that is the magnetic field, direction of magnetic field is perpendicular to the plane of dl and r. So we can write the vector form of Biot-Savart's law from this equation. That is dB is equal to mu 0 by 4 pi I into dl cross r divided by rq. So this is a vector form of Biot-Savart's law. The direction of the magnetic field is determined using right hand screw rule. According to right hand screw rule, if a screw is in our right hand and we are placing the screw perpendicular to the point P in such a way that the screw is perpendicular to the plane P. Now if we are rotating or moving the screw in such a way that it is in the direction of dl to r, then the screw advances in the direction of the magnetic field. Thus, we can determine the direction of magnetic field using right hand screw rule. Now, we will consider some special cases. The magnetic field depends upon the angle between dl and r, that is current element and the position vector r. Now, the first case is that if theta is equal to 0 degree. If theta is equal to 0 degree means we are considering a point which is on the axis of this current carrying element. So if theta is equal to 0 degree, sine 0 will be equal to 0. Then dB is equal to 0. That means the magnetic field is 0 anywhere on the axis of the current carrying element. Now the second case. In the second case, we are considering the theta as 90 degree. So if theta is equal to 90 degree, sine 90 is 1. That means dB is maximum. So dB is maximum when theta is equal to 90 degree. So we can say that dB is maximum when a plane is passing through the current element and perpendicular to the axis of this conductor. Now, we will discuss the similarities between Biot-Savart's law and Coulomb's law. According to Biot-Savart's law, dB is equal to mu 0 by 4 pi I dl sin theta divided by r square. According to Coulomb's law, force is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by r square. So here comes the first similarity. First similarity is nothing but it is inversely proportional to the square of the distance between them. Both are inverse square law. Second similarity, both are long range fields. Now comes the last similarity is that both obeys the principle of superposition because the magnetic field as well as the force. In Biot-Savart's law, the magnetic field linearly depends upon the source, that is I dl, and force in the Coulomb's law also linearly depends upon the source, that is Q1 and Q2, electric charges. Since they linearly depend upon the sources, they obey the principle of superposition. Difference between Biot-Savart's law and Coulomb's law. First difference. Magnetic field in Biot-Savart's law, magnetic field is produced due to the vector source. That is I dl is a vector source. But in the case of Coulomb's law, the force is produced due to the scalar source. Electric charge is a scalar source. Second difference. In Coulomb's law, force is along the displacement vector. But in Biot-Savart's law, the magnetic field is along dl cross r, or it is perpendicular to dl and r. Now, the third difference is that there is an angular dependence in the Biot-Savart's law, where in Coulomb's law, there is no such dependence. Here, we will find the relationship between mu 0, epsilon 0 and C, where mu 0 is the permeability, epsilon 0 is the permittivity and C is the velocity of light. We know that 1 by 4 pi epsilon 0 is equal to 9 into 10 raised to 9 Newton meter square Coulomb raised to minus 2, and mu 0 by 4 pi is equal to 10 power minus 7 Tesla meter raised to meter ampere raised to minus 1. Now, we will divide these two equations. Okay, 1 divided by 2. It is mu 0 by 4 pi into 4 pi by epsilon 0 divided by 1. 4 pi cancels. This implies mu 0 epsilon 0. So it is mu 0 epsilon 0. Mu 0 epsilon 0 is mu 0 by 4 pi into 4 pi epsilon 0 by 1. So substituting the values for mu 0 by 4 pi, it is 10 raised to minus 7 into 4 pi by epsilon 0, 4 pi epsilon 0 divided by 1. It is nothing but 1 divided by 9 into 10 raised to 9. Doing calculation, we will get mu 0 epsilon 0 as 1 divided by 3 into 10 raised to 8 the whole square. Now what is 3 into 10 raised to 8? It is nothing but c. So here you got the equation as mu 0 epsilon 0 is equal to 1 by c square, or c is equal to 1 by root of mu 0 epsilon 0. This is the relationship between velocity of the light, permeability and permittivity. First application of Biot-Savart's law. It is to find the magnetic field due to a straight current carrying conductor. So, in order to apply Biot-Savart's law, here I am considering a straight current carrying conductor XY. We wish to calculate the magnetic field at the point P. Let dl be a small current element. Now, let r be the position vector of point P with respect to dl. Let PQ be the perpendicular distance to xy, where that distance is given as a, and I is the current carrying by this conductor. Now let this angle be theta, that is angle between dl and the position vector r is theta. According to Biot-Savart's law, dB is equal to mu 0 by 4 pi I dl sin theta divided by r square. Here we will consider the triangle OQP. So here I am redrawing the triangle OQP, where QP is A, OP is R and OQ is L. OQ is L. Let the angle between it is phi, here it is theta, and this is 90 degree. So here we are considering the triangle OQP. In the triangle, according to the angle sum property, sum of the angles of a triangle will be always equal to 180 degree. So here theta plus phi plus 90 degree is equal to 180, or theta plus phi is equal to 180 minus 90, which is equal to 90 degree, or phi is equal to, or theta is equal to 90 minus phi. So in sin theta, instead of theta, we can write it as 90 minus phi. So sin theta is equal to sin 90 minus phi. According to the trigonometric relationship, sin 90 minus theta can be written as cos theta. So here it is sin 90 minus phi. Sin 90 minus phi can be written as cos phi. So sin theta is equal to cos phi. Let this equation be number 1. Sin theta is equal to cos phi. Now we will find cos phi. Cosine of an angle is adjacent side divided by the hypotenuse. So adjacent side of phi is A and the hypotenuse is R. So cos phi can be written as A divided by R. Or R is equal to A by cos phi, where 1 by cos phi is equal to A sec phi. So R is equal to A sec phi. Let this equation be number 2. Now we will find the tangent of phi, that is tan phi. Tan phi is equal to opposite side divided by adjacent side, that is L divided by A. So tan phi is L by A, or L is equal to A tan phi. Now we are differentiating both sides, so dl is equal to A sec square phi d phi. Let this equation be number 3. So here we got 3 equations. The first equation is for sin theta. Sin theta is equal to cos phi is the first equation. Then R is equal to A sec phi is the second equation. And dl is equal to A sec square phi d phi is the third equation. We will substitute all these 3 equations in the Biot-Savart's law. Instead of dl, we can substitute A sec square phi d phi. Instead of sin theta, we can substitute cos phi, and instead of r, we can substitute A sec phi. Now we will substitute all this equation in dB. So dB is equal to mu 0 by 4 pi I. Instead of dl we can write it as a sec square phi d phi. Instead of sin theta cos phi divided by, instead of r square, a square sec square phi, because r is a sec phi, so r square is a square sec square phi, where sec square phi cancels, a and 1a in the denominator cancel. Now the equation becomes dB is equal to mu 0 by 4 pi I cos phi d phi divided by A. According to the right hand rule, the direction of magnetic field due to all current elements will be same, that is into the plane of the paper, normal to the plane of the paper. Now, this magnetic field can be find out by integrating this equation within the limit minus phi 2 to phi 1. So here I am integrating dB. B is equal to integral of dB within the limit minus phi 2 to phi 1, which is equal to, where mu 0 by 4 pi, mu 0 I by 4 pi a is a constant. We can take it outside the integral. So mu 0 I by 4 pi a integrating minus phi 2 to phi 1 cos phi d phi. Integral of cos phi is sin phi. So B is equal to mu 0 I by 4 pi a sin phi within the limit minus phi 2 to phi 1. Applying the limit, upper limit minus lower limit, we will get an equation for magnetic fields. B is equal to mu 0 I divided by 4 pi a sin phi 1 plus sin phi 2. So this is the equation for magnetic field due to a straight current carrying conductor. Applying Biot-Savart's law, we will be getting this relationship, this expression for the magnetic field mu 0 I by 4 pi a sin phi 1 plus sin phi 2. Now we will discuss two special cases. So the first one is that if xy, that means if the conductor is infinitely long and if the point P lies in the center of the conductor, then phi 1 will be equal to phi 2, which is equal to 90 degree. Substituting these values here, B is equal to mu 0 I by 4 pi a sin 90 plus sin 90, where sin 90 is 1. So this equation becomes mu 0 I by 4 pi a 1 plus 1, that is 2. So 2 and 4 cancels. So the equation becomes B is equal to mu 0 I divided by 2 pi a. This is the equation for magnetic field. Due to a straight current carrying conductor, if the point P lies on the center of the conductor, B is equal to mu 0 I divided by 2 pi a. Now the second special case is that if the point P lies at the end, if it lies on the x or in the y, one angle will become 90 degree or other angle is 0, that is phi 2 becomes 0. So if the point P lies on any of the end of the conductor, one angle becomes 90, another angle becomes 0. So substituting these values here, B is equal to mu 0 I by 4 pi a sin 90 plus sin 0, where sin 0 is 0, sin 90 is 1. So the equation becomes B is equal to mu 0 I divided by 4 pi a. This is the expression for magnetic field at a point which is in the length or end of the conductor, end of the current carrying conductor. We will plot a graph for the variation of magnetic field with the distance. From the equation, it is clear that the magnetic field is inversely proportional to the distance. So, if I am plotting a graph where B on the x-axis and distance in the y-axis, since it is inversely proportional, this will be the nature of the graph. We can determine the direction of magnetic field due to a straight current carrying conductor using right hand thumb rule. So if this is a current carrying conductor and current is in the upward direction, according to right hand thumb rule, hold the conductor in your right hand in such a way that thumb is in the direction of the current. So current is in the upward direction. So thumb should be extended in the direction of the current. Then curved fingers will give the direction of the magnetic field. This is right hand thumb rule. Using this right hand thumb rule, we can determine the direction of magnetic field due to a long straight current carrying conductor. There is one more rule to find out the direction of magnetic field, and that rule is Maxwell's corkscrew rule. According to Maxwell's corkscrew rule, if a right-handed screw is rotated along the wire in such a way that the screw advances in the direction of current, then the direction of thumb, that is the rotation of thumb, gives the direction of magnetic field. So that's all for today. There are 2 more applications for Biot-Savart's law where we will discuss it in the next video. So thank you for watching me.